Hi, my name is Aaron, and I'm one of the developers with the Naomi project. And today I'd like to talk to you about smart speakers, some of the decisions that are being made right now, and why they don't make sense, or how they do make sense, and some of the things that you could do to help our project preserve your freedom and choice in the future. Smart speaker ownership is growing rapidly. This is a graphic from Adobe Digital Insights in 2019 that shows that in January 2018 already more than a quarter of American households contained a smart speaker. And I'm not talking about cell phones and computers and things that have digital assistants in them now. I'm talking about specifically smart speakers. And by February of 2019, that had risen to 1/3 of all American households. My great concern about this and the rapid growth is that I think that people are misunderstanding how these devices actually work. And I found this quote that I like from a November 2018 issue of the Atlantic magazine that gives a good description of how somebody might understand this. This is Judith Shulevitz, and says, the speakers possess artificial intelligence, can conduct basic conversations, and are hooked up to the internet, which allows them to look things up and do things for you. So I created a diagram for this based on my understanding of what those words mean. And to me, what that means is that you talk to the speaker interprets what you're saying, creates a request, sends it out to a cloud server someplace. The cloud server then responds, and the speaker is able to interpret that, turn it into an answer, and give you an answer. But the way that these actually work is that there is a server. Basically everything that the smart speaker does goes through this server, and the smart speaker that's sitting on your shelf is really more like a telephone receiver. I mean, it basically is smart enough to listen for a wake word, which is a fairly easy thing to do in speech processing. And then once it hears the wake word, it starts sending your audio straight to a server someplace. And that server then converts that to text, figures out the meaning of it, creates a request, and then turns that information into an actual speech recording that it sends down to the device that just plays the file as the response for you. And I think one of the things that really clued me in that people were misunderstanding this was the amount of controversy over the last couple of months about employees at Apple and Microsoft and other places having access to these recordings. So here's another quote from Judith Shulevitz that I found really interesting in terms of the goals of the smart speaker companies. These and other tech corporations have grand ambitions. They want to colonize space, not interplanetary space, everyday space, home, office, car. In the near future, everything from your lighting to your air conditioning to your refrigerator, your coffee maker, and even your toilet could be wired to a system controlled by voice. So if you were designing a system that you needed to work perfectly in order to flush your toilet, I think your primary concerns would be reliability and security. and you probably would not require an always-on internet connection or a server that somebody else owns that never goes down. And it's really not necessary that they be set up that way. There is already commercially available software such as Dragon Naturally Speaking, which is good enough that it's used for medical transcriptioning, and it will run off of an individual doctor's laptop. Doesn't require a whole set of corporate servers. There's also several free and open source projects that are already available, including Pocket Sphinx, which is a Carnegie Mellon project, Caldi, which is more associated with Johns Hopkins University. Mozilla Deep Speech is actually a project of Mozilla, which are the people who make the Firefox web browser. And Julius is a Japanese speech-to-text project. And all of these can be used with Naomi if you want to keep your audio on your server. Here is a list that I got from an article by Gaida, Lang, Petrick, Proba, Molatawi, and Sunderman Oft, comparing the word recognition rates for a bunch of these different libraries back in 2014, and you can see that in one case they were even able to get as low as a 6.5 word error rate, which is pretty good. It means that the computer's only missing about 6 or 7 words out of every 100 words that you speak to it. And this is how Naomi works, is you talk to the speaker, which could be a home computer or it could be a Raspberry Pi, then interprets what you're saying, sends a request up to a cloud service, gets the information back, and is able to actually format a response and give it to you directly. It contains speech-to-text and text-to-speech, and one of the things I'm most excited about is that starting this year you can actually train your own speech-to-text models, which makes this able to be adapted for a particular speaker or a particular set of speakers to be able to understand what they're saying and how they speak better. Here are some things that we'd like to have. A lot of these are technical. Some of them are not. I mean, if we could just have people testing this software, that would be a huge help, as well as going through documentation, letting us know when things don't make sense or are hard to follow, or even writing the documentation, which is available for the public to edit and submit for one of the maintainers to actually accept into the project. These would all be incredibly helpful, so please visit our website, take a look at the forums, the documentation, download this yourself, try it out, let us know how it works for you. Thank you very much.